Okay.
Dr. Valerie Shoup is president of Heritage Institute of Sustainability, a consulting firm headquartered in Dallas, Texas. Dr. Shoup earned her Bachelor of Science in Mechanical Engineering at Oklahoma State University, her Master of Business Administration at the University of Texas at Dallas, and her Doctorate of Business Administration at Walden University. She holds a professional engineering license in the state of Texas, is certified energy manager. She is investor confidence project certified for both project development and quality assurance, and is a certified water harvesting practitioner. She has received multiple awards and honorariums for her work, including D Magazine Excellence in Healthcare Innovation finalist, STARS Award for Excellence in Materials Management, Working for Clean Air Award for her Best Business Operations, and TCEQ Innovative Operations finalist. She has presented multiple papers, both nationally and internationally, on topics including engineering, sustainability, and healthcare. Dr. Shoup spent 16 years holding positions as Director of Utilities, Director of Sustainability, and Assistant Vice President of Hospital Facilities at UT Southwestern in Dallas. Prior to her tenure at UT Southwestern, she held a variety of engineering positions, including Energy Engineer at Eastman Kodak and Mechanical Consulting Engineer at Lockwood Green. Valerie, we turn the time over to you for your presentation. Thank you.
Okay, thank you so much, Brian, and thank you everybody for coming today. So without further ado, let's talk a little bit about water conservation, which is one of my passions. So, and you guys pay real close attention in the event you're doing the trivia contest today. You will find some answers to the trivia questions. So about 71% of the earth is covered in water, but only 1% is drinkable. Industries depend on water for operations, and it's a multi-billion-dollar issue. As the population continues to grow, water conservation becomes more important. Oftentimes, facilities engineer will overlook water when they're putting together their energy management plan. And today, I hope you all will understand how important it is to include water conservation in your energy management plan for your facility. So here are our learning objectives. We want to talk a little bit about why you all should care about water management. And we'll talk a little bit about some unknown facts about water rights. And then we'll talk about the components of a water management program. And you will understand the basic approaches for water management, including benchmarking, measuring, and documenting water consumption. And you will understand the upsides of a vigorous water conservation program. So why is water conservation important? What are those components of a water management plan? How are you going to benchmark, and how are you going to approach water conservation? As we said earlier, about 71% of the earth is covered in water, but only about 1% is drinkable. And as you know, all living organisms require water to survive. All businesses depend on water for operation, and loss of water can really be a multi-billion-dollar problem. So many folks don't know that about 41% of the water is used to cool thermal plants in the United States. So whether you use water in your cooling towers directly or indirectly, through DX systems, the electricity that's needed to create power uses a lot of water. And you know, you can switch to air-cooled systems, which will save about 75% of the water consumption, but you may increase your electrical consumption by about 4 to 5%. And also, a lot of folks don't realize that not all lakes and rivers in Texas are safe to swim in or to eat the fish out of, and not all beaches are safe either. So that's just kind of a sidebar from engineering for when you all go out and enjoy water recreationally. But if you go to the environmenttexas.org, you can find more about the water systems in Texas. So how much do water rates really change? I know a lot of people might say, well, we don't pay that much for water. But what I was amazed to find out is the differences in water costs across the state. In South Texas, it is much more expensive than it is here in North Texas. But in North Texas, also over a very short period of time, water rates have gone up, almost doubled. And across the country, the Circle of Blue saw a 41% rise in water costs over 5 years in 30 US cities. So why is water conservation important? We know that supplies are finite and they decline as the population increases. Our agriculture and industrial businesses depend on water to remain viable, and you'd be amazed at how much of the economy of Texas depends very much on agriculture. So water, if we lose water in Texas, it could be a huge problem. And then we talked about the power plants using 41% of the water supply. So we have a responsibility to our environment, and that really should be the most important thing of all. But for those who look primarily at economics, water rates continue to rise every year. So we're going to talk today about integrated urban water management and what it is. So according to authors of the book entitled Integrated Urban Water Management, it is described as a practice of managing freshwater, wastewater, and stormwater as components of a basin-wide management plan. But I like to put things in simpler terms. So according to Dr. Shoup, integrated water management for the end user is about reducing use, recycling water you have when and where you can, and then capturing the water on your property and storing it for future use. So now we'll jump into the components of a water management plan. So some of you all may have been shocked by the cost of water escalation over time, but now let's talk about our individual options for planning water today and into the future. Whether you're a company or a public entity, there are many things you can do. So we will discuss the components of water management, the approaches you can take, and give you practical examples and challenges you might find along the way. So basically the components start with plan what you want to do, you gather data, you get stakeholder engagement, you decide on an approach, you retain expert advice, then you re-look at your plan, then you implement and reassess. But I wanted to let you guys know that you may already have an idea of what you want to do to manage water at your site. So you may already have a plan. But the thing to do is to clear your mind and gather lots of data and then bring in stakeholders. So together you can decide on an approach. And then expert advice, of course, is very important. So look at where are you using your water? How are you using your water? Who is using the water? What can you control? When are you using the water? How much are you paying for your water? Are you taking advantage of sewer credits? Where does the water go when you drain your cooling towers? Where does the water go when you have a chill water shutdown? What water systems are once through? Can we reuse this water? These are all great questions to ask. So the first thing you want to do on your site is to know how you're using your water. So normally when I go do a water audit on a site, hopefully you will find that you have domestic water meters and your sprinkler water meters. So I always put together a graph because I'm a visual person. I like to see visually how much water am I using each month. So I look at the gallons per month and kind of look at trends and see if there's anything odd about the trends. Everybody, I mean, you kind of have an idea of what your graph should look like. Now, you also know if the water goes up significantly in the summer months that your client likely has a cooling tower. So before I ever even go to a client site, I gather the information and I put it in a graph So I have a feeling before I ever even go to the site of how and when the client's using water, and then I can ask them the appropriate questions. I also look at each of the water meters individually. Some sites will have multiple buildings. And so what I'll do is I'll graph each one of the buildings so I can get an idea of what might be on which meters. I can identify which meters likely have the cooling towers on them. I can look at how is the lawn being sprinkled, see if there's anything funny about the sprinkler system. So there's a lot you can ascertain before you ever even go to a site by getting the bills, getting the meter data, and putting it in a graph format so you can see how a site is using their water. And then, of course, there are benchmarks. Now, some sites are lucky and they'll have multiple buildings, or say in a university system, like when I was in UT system, you would benchmark against other universities. So you kind of had a good feeling for how you fall out in water use. But if you are not, part of a bigger system and you're just a single building, there is the water intensity use in the CBEC database. So you can go to there and get an idea of how many gallons per square foot you're using versus what other types of facilities are using that are similar to yours. Now, keep in mind, depending on what you're doing, you may want to use other benchmarks such as gallons per employee or gallons per acre. So then you also want to look at your water. This is what I call your water cost index. So you have your water use index, and then you also have your water cost index, and it helps you do your monthly budgeting. So then you benchmark your water consumption. You can benchmark against a CBEC database or building to building. You can look at water per gross square foot, water per acre, water consumption per employee. Sometimes hospitals will look at water consumption per patient bed. And in cities benchmark at water consumption per capita. Now, so here are the approaches to water management plan. And you may say that this looks obvious, but I can't tell you how many people who have asked me to come design water harvesting when steps 1 and 2 have not even been considered. So the basic approach is to go from the least expensive to the most expensive. So capturing gray water effluent and water harvesting can seem daunting at first, but there's very simple ways to do that, and we will talk about that today. So in regard to conservation, some cities offer a free water audit, such as Dallas or Fort Worth. But if you're in Austin, Austin will pay a partial rebate to have a water conservation expert come in and audit your system. So you also want to look at these are the main locations you want to look at: your sprinkler systems, look in your kitchens, laboratories, look at your domestic fixtures, your process cooling systems, and your cooling towers. Now, sprinklers can use as much as 50% or more of your property's water use. So you want to look at things like, do you have a rain sensor? Are you watering more than you need? What type of landscaping do you have? Are you mulching to retain water? Have you created water basins on your site? Are you controlling the runoff on your property? Can you create retention ponds for watering your landscape? And I do that sometimes when I do big reviews of, like I did a assisted living center in Oklahoma, and they were on 15 acres. And so I had recommended that they put in retention ponds to create a way to sprinkle their landscape rather than buying all this water from the city and letting it run off and go right back to the city. So in the kitchens, you look at things like, are the staff composting food waste and not putting it down the drain? How are the staff defrosting food? Are they just running water over the chicken, or are they defrosting food in their refrigerator? Dish disposers, those things are one of the worst things they ever put put out there. You can replace your dish disposers with baskets to capture food waste. And then you can look at spray heads. Do they have more water than they need? And then look at hand sinks and the kitchen sinks. What is the GPM of all those devices? In laboratories, RO systems use a ton of water. So you can look at how the RO systems are designed and how are they running. Domestic fixtures, sorry about that. How many gallons per flush? Okay, so on domestic fixtures, how many gallons per flush? Does the flush valve match the stool? Process systems, how many once-through systems do you have? Can you reuse the water? And cooling towers, are your cycles of concentration where they need to be? And speaking of cooling towers, when you look at this drawing right here, so whenever I go look at a cooling tower, the first thing I do is go to the towers and I take photographs, and then I find out what's going on with the tower. Well, in this particular picture, as you can see, there's the water tends to be green. So that says something about your water treatment program. The water is coming out of the valve, and believe it or not, this system is not running. So you can see there's corrosions on members of the tower. There's calcification on the water valve. So a cooling tower is always a big place to look. I've seen lots and lots of towers where the float valves are stuck open or not working properly. So you can use a lot of water in your towers. So in regard to cooling tower opportunities, we know about cycles of concentration, your blowdown controls, level controls, overflow alarms. You can tie your overflow alarms into your EMS. There's many different water treatment technologies, so you can consider the various kinds and decide what works for your facility. You have your annual maintenance and cleaning of your cooling tower inlet screens. You have drift eliminators. You want to be sure that you are tracking your conductivity at or above the 1600 microsiemens per centimeter minimum standard. And you also want to calibrate your tower controls regularly. And you want to control biological growth and scale. And then if you can, return air handling unit condensate to the cooling tower or use it for irrigation. And I saw where at one facility I looked at, they actually put 55 gallon drums in their air handling unit rooms and took the condensate and with little bitty pumps pumped it out of the drain pans and into the 55 gallon drum. And then from the 55 gallon drum, they put it in the water return system back to the towers. So it's amazing what you can do if you're creative. And then of course, with cooling towers, you always want to do structural inspection every 5 years to assess damage and mineral buildup. There are many alternative scale inhibitors. So you can use a water softener. So softening the water allows increased cycles of concentration. It reduces chemical consumption and it eliminates the need for feeding chemical scale inhibitors and or mineral acids, since soft water is non-scaling. Soft water also helps maintain the pH above 9 standard units, which controls the growth of pathogens. You can also do side stream filtration, which removes the dissolved solids from the tower water. Sand filters remove finer particles than centrifugal filters, but do require additional maintenance. Then they have physical water conditioners. Just one brand I'm familiar is HydroFlow, but I've since learned there are many brands of water conditioners. And it basically causes the dissolved calcium to precipitate in the water stream and prohibits it from attaching to the pipes and equipment. And it reduces the amount of makeup water, energy, and chemical use in the towers while improving water quality. And then of course on chillers and HVAC equipment, you want to clean and inspect your coils annually. Ensure cooling coils on HVAC systems are cleaned annually. Consider bipolar ionization for air handling units to keep coils and internal equipment free of bacteria that can reduce heat transfer. You can ensure your filters in your air handling units are kept clean to reduce pressure loss in the system and efficiency. And in regard to filters and filter banks, all of them that I look at, they all have bypass. So the first thing obviously would be to be sure that your filter banks aren't bypassing, and that will also help keep your coils clean and increase your heat transfer. And then if you have strainers on your chilled water system, you want to be sure that, you know, the strainers are kept clean and inspected. And it'll also tell you your water treatment, whether you have scaling in your pipes and that type of thing. On your heating water system, if you monitor supply and return water temperatures and staged, you can minimize your energy use. And one of the things I did on a hot deck, cold deck system was I actually lowered my heating water temperature based on the pressure on my hot deck system, and it saved about 10% of the energy use on the hot water side. And then you can monitor water quality in your heating system to maximize heat transfer. And of course, once again, keep your strainers clean. A lot of times folks don't really think about water features, but if you have water features at your facility, there is a lot of opportunity to save water. So water used for startup and makeup water in new ornamental fountains may be supplied by alternative on-site water or municipally reclaimed water. So if you have ways that you can capture condensate, you can fill your water features with that. But the water features that, you know, the quality of the water doesn't have to be as sterile as if you were drinking the water. If alternative on-site water or municipally reclaimed water is not available within 500 feet of the project site, potable water is allowed to be used for water features with less than 10,000 gallon capacity. So ornamental fountains or new ornamental water features may be equipped with meters and leak detection devices that shut water feature off if a leak greater than 1 gallon per hour is discovered. And also ornamental fountains or other ornamental water features may be installed with a recirculating system. And the other thing I didn't mention also, I don't know if I don't remember if it's in my presentation or not, but be sure you have makeup meters on your swimming pools as well, because swimming pools, people don't even realize it. It's not until they've been losing water for a long time that they really realize their swimming pools are leaking. So if you have pools in your facility, be sure you have a makeup meter on the swimming pool. So here's a list of standards for metering. So, and this is based off of code. All buildings intended for daily occupation for water use and equipment should be metered separately. A separate meter or sub-meter should be provided for all cooling towers, subtenant space greater than 50,000 square feet, or water consumption that exceeds 500 gallons per day, such as restaurants and food service. Indoor and outdoor swimming pools and in-ground spas with makeup water supply lines should have metering. Makeup to closed loop hydronic chill water greater than 50 tons or hot water systems greater than 500,000 BTUH. Cold water makeup to water heating boilers of more than 500,000 BTUH. So set up monitoring of water meters and identify where the meters serve. And you want to go ahead and set up water use indices for each of your meters. And then with that, you can set and track savings goals. Okay, so we talked a little bit about pools and spas that should be equipped with recirculating filtration equipment, and they also should be sub-metered. And then pools with a capacity of 50,000 gallons of water or less should use cartridge filters or regenerative coated media filters The cartridges should be reusable type. In-ground pools with splash troughs should drain back into the pool system. Pools and spas should be covered when not in use where it is practical. Okay, so we were talking about cycles of concentration. So I kind of like this slide only because you can really see visually that as your cycles of concentration increase, you can see where they increase from 3 to 8, and chiller tonnage from 100 to 5,000 tons. You can see as the higher the cycles of concentration, the less water that you use. So that cycles of concentration really is important. The other thing is, if you're not aware of what the International Energy Conservation Codes require, be sure you become familiar with those codes. Now, there are different types of devices out there that actually exceed the International Energy Conservation Codes. Like I know some apartment owners who are putting in 1 gallon per flush, like the Niagara Stealth that have the vacuum assist. Urinals, you can get them at 1/4 gallon per flush. Sink aerators should be, like in the bathrooms, 0.5. And you know, it really depends on the sink aerator. 0.5 is good for just about everything, but in the kitchen, you'll probably want something a little higher than that. Cooling towers, try to achieve not less than 5 cycles. Boilers, conductivity controllers. You know that vacuum and process systems, the water must be recycled. Sterilizers, that's a huge one. I can tell you most hospitals I go to are not recycling sterilizer water, and you can actually get a retrofit kit for your sterilizers that will recycle the water. Kitchen garbage disposers, I say bad news, compost your food waste. We actually put in a food waste composter at UT Southwestern that you could capture the food waste and put it in this composter, and it's amazing. The enzymes just turned it into water and you could put it down the drain. I mean, life was good. Washing machines, of course, you want Energy Star because of how much water they'll save. And then once we talked about pools and sprinkler systems. Now, I went to a sprinkler system class not too long ago, and it is amazing. The technology has really evolved. So if you have an old sprinkler system that doesn't have all the bells and whistles, I would highly recommend looking at your sprinkler systems because there is some really neat controls out there for sprinkler systems. And then one thing people don't think about, and when they do their water savings, is, you know, there is a cost to pumping water, and maybe you want to use the cost of pumping water as your cushion when you estimate your savings. But there is a real cost of pumping water. So obviously, if you're in a big facility where you have to, you know, pump your domestic water, there's a huge savings if you're using less water. And then, of course, heating. People often don't think about the heating water savings, but you can calculate how much of your natural gas or electricity you can save if you are saving on heating water. Now, the big thing about conservation is awareness, education, and behavior change. And I can tell you, when I went to water management group in Tucson, Arizona for a week, it was a culture shock. This is a picture of where I was taking my classes. And as you can see, yes, we really did have to go to the bathroom in that outhouse. And it was actually a composting toilet. And what is amazing is, okay, so there was no water in the outhouse at all, but they used sand or sawdust to put on top of whatever went down the toilet, and then they would compost it, and they actually put it back in the beds where they were growing fruits and stuff like that. And it's amazing. You would have thought it was the smelliest thing in the world, but it wasn't. You could not even smell it. So if you compost correctly, there is not a negative odor to doing that. And then if you see in the foreground, that bucket on the string, anytime anybody says that you cannot wash your hands at less than 0.5 GPM, I say not so much, because that bucket on a string, it had about the size of a pencil water coming out, and we used soap to wash our hands, and it worked like a champion. So before you spend, so moving right along, before you spend money on rainwater capture, consider making your property a living sponge. So an example of Earthworks is you start at the highest point of your watershed and you work your way down. And so in the picture, it's kind of small on the right-hand side. You can see this is in Arizona at one of the universities. Their air handling units were on top of this parking garage, and then they made a waterfall into a water feature. And then the water feature pond, they used that to sprinkle their lawn. So it's called stacking functions, using the water for more than one purpose: growing food, reducing erosion, sending it to a pond, etc. And here's a picture of Earthworks, only because Brad Lancaster draws better than I do. You can see in the top picture a home where the water is just running off the roof and running off the landscape and into the storm sewer. And you can see in picture 2 where you make your landscape a living sponge. Here's a picture from Tucson, Arizona, where we were actually creating a living sponge in this house in Arizona. They also were putting in an outdoor shower where they were capturing rainwater. This is City of Kemp. They put in a watershed where they captured the water off of a bridge they have outside of their city hall. They would rainwater capture and then create a watershed through permeable soils and also by using native plants. So before you go to water harvesting, of course, we said first you want to conserve and then you want to implement Earthworks. Then if you still need water, you can think about different types of harvesting, such as condensate recovery, then your rainwater harvesting, and groundwater harvesting. Now, I wanted to let you know that water harvesting is really pretty, it's not difficult. I mean, it may seem overwhelming at first, but you basically just look at all your square footages and you figure out how much your runoff is, and there's correction factors for all that. You can find those in the textbooks, but you can figure out how much water you can harvest. And sometimes your property will actually have runoff from adjacent property. So when it's raining, you should go out and just, as we talked about earlier, that thoughtful observation to see where is the water coming from and where is it going. And of course, we talked before about the fact that air handling unit condensate is clean and can be captured and returned. So this is a house. So this is basically small volume water harvesting, but it works the same as large volume water harvesting. You take the water from wherever you're capturing it, you put it through a filter before you put it in your pipes. And then your pipes go down. There's a first flush off to the straight pipe that's going down is a first flush, which captures the dirt first, and then it overflows into your piping and goes underground into your water harvesting tanks. And then in the third picture on the right-hand side, you see you always have an overflow basin. So if your tanks overflow, you have a place for it to go to. And of course, I mean, you should be able to calculate how much your overflow is and make your basin as big as it needs to be. This is a picture of water harvesting management in Tucson. They literally anytime anybody says that you can't harvest enough water to survive in Texas, I say not so much. This is Tucson, Arizona. They harvested all of their water. It went into a tank underground. And then from the tank, it was pumped through a filter system and through UV. They used water harvesting management. 100% of their water was from rainwater capture. So also I have to say, all you Texans out there, is no more excuses. Now, this is a lovely picture. Many people recognize one of our dear friends in Plano who is actually water harvesting in large volume. One of the things, they're doing a great job of water harvesting, but I would recommend looking at the landscape and considering more basin capture. As you can see, where different parts of the landscape slope, you'll have quite a bit of runoff, but you can create in each one of those downhill sections a basin to capture the water. And once you have graded your property properly where you can capture the water, then you will really find that you don't need near as much water to sprinkle your landscape. So what can you capture in regard to gray water in Texas? You can capture washing machines, bathroom sinks, bathtubs, and showers. And this is basically a picture, thank you, Brad Lancaster, once again, because he draws better than I do. If he's showing where the bathroom tub is coming outside and actually overflowing into the yard. Now that's kind of a rough way to do it, but what I prefer to do is to put in a gray water capture system. So this is an infiltration basin we put in on that project in Arizona. And what this does is, because, you know, your water can be erratic, or, you know, when a washing machine is discharging, it can be a lot of water. So you put it in an infiltration basin. So you calculate the volume of water, you perk test your soil, which will tell you how long it takes the water to percolate into the soil. And then from that, you can design your infiltration basin. So the important thing here is knowing where to start. Start small, know your constituents, and be prepared to deal with resistance to change. I can't tell you how many people get upset about 0.5 GPM aerators in the bathroom, which is ridiculous. Anybody can wash their hands with that. And as you see, the pictures here is my house before I knew how to design a rain barrel. So you will see quite a bit of difference. And this, the after picture, this is after I learned how to properly design a rain barrel. So in my yard, I have 5 rain barrels around my house, and that is how I water my yard. So in summary, water is a precious asset, and the availability is expected to decline, especially in Texas, because everybody's moving to Texas, and there's more industries moving to Texas, and we all know industries use a lot of water. So it's really important that everybody really care about water, and that we benchmark our water and understand our use patterns. And then once you understand your use patterns, how can you conserve? And then look at your property for earthworks. Do you really need to be running your sprinkler systems as often as you are? Then look at gray water capture and reuse. I mean, that is really a good step towards water conservation. And then, of course, rainwater capture, where you put in your big tanks, is something else you can do to maximize conservation. So saving energy also saves water. So if you have a rigorous energy conservation plan, you'll find, especially if you have cooling towers, you'll see that water savings at your plant, but also with a rigorous energy conservation plan, you won't see the savings at your plant, but you can feel good knowing back at the power plants across the state, they'll be using less water. So conserving water saves water, electricity, and natural gas consumption. And here's a lot of really good references. We're excited. I'll leave that up. And does anybody have any questions?
Hi, Valerie. This is David Muzzy.
Hi, David.
I don't know if you mentioned, but the waterless urinals, there's a company out there that makes a device that on urinals